Hello, it's Paige Green from Paige Green's Tutoring, and today we're going to be having a look at converting from ratios to fractions and fractions to ratios. So let's go through a series of questions before you have a practice of this on your own. It says here, the ratio of chocolate cakes to vanilla cakes is 4 to 5. What is the fraction of chocolate cakes? Now, in order to do this, the best way to think about it is thinking of the ratio as parts. So we've got 4 parts, which are chocolate cakes. We then have 6 parts, which represent the vanilla cakes. Now, when we write a fraction, we always write how many we have. We have over the total amount. So if we think about this, well, how many chocolate cakes do we have? Well, we have 4 parts. So we have 4 chocolate cakes. And then what is the total amount? Well, the total amount is how many parts I've got all together. So if I count this, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my fraction of chocolate cakes would be 4 over 10. And we can simplify that by dividing the top and the bottom by 2 to give us an answer of 2 over 5. So the next question then says, what is the fraction of vanilla cakes? Well, we can see we've got 6 parts, which are vanilla. And again, the total amount still remains as 10. So we have 4/10, which are chocolate, and 6/10, which are vanilla. Again, we could simplify this fraction by dividing the top and the bottom by 2. So we've got 3/5. And we can tell our answer is correct because 2/5 add 3/5 is 5 over 5, which is a whole. So obviously we've got the whole amount that we've got there. Let's have a look at this next question, just bringing in 3 parts instead. So it says here, the ratio of red, green and blue balls in a bag is 7 to 3 to 5. What is the fraction of red balls? Now let's have a think about it like parts again. So 7 parts are red, 3 parts are green, and 5 parts are blue. Therefore, we can say we have 7 parts which are red balls out of a total. Now let's have a think. We've got 7, add 3, which is 10 parts, add another 5, which is 15 parts. So we have 7 out of those 15, which show us the red balls. Let's have a look at the next one. So exactly the same process. We've got 7 parts which are red balls, 3 parts which are green, and 5 parts which are blue. What is the fraction of blue balls? Well, we said 5 parts are blue out of, again, the total amount of parts, which is still 15. And we can simplify this answer by dividing the top and the bottom by 5, which would give us a third. And then the last one says, what fraction are green? Well, let's have a look again. 7 are red, 3 are green, 5 are blue. So 3 parts out of those 15 are green. And again, we can simplify this by dividing the top and the bottom by 3, which gives us a fifth. So you can see how we're using exactly the same process, but we're just adding 3 parts of a ratio instead of just 2. Now we're going to have a look at converting from a fraction into a ratio. So here it says pink paint is made by mixing red and white paint. 2/7 of my pink paint is red. What fraction is white? Well, we have to use the idea that when we add fractions, they should always give us a whole. So what I need to think about here is 2/7 plus something is going to give me the whole amount of pink paint that I've got. And it's easier to think of a whole as 7 over 7. So I can see here, well, I would need to add on 5/7. So that means that 5/7 of my mixture would be white. The next one therefore says, what is the ratio of white to red paint? Well, we know 2 out of the 7 parts are going to be red. 5 out of the 7 parts are going to be white. Therefore, we can say 2 parts would be red, 5 parts would be white. So we're almost just taking the numerator from the top of each of those. But it's really important, if a question asks you what is the ratio, you first work out the other fraction. So here I know that I've got 2/7 of red, so I have to work out how much white I have before you can make that association. So let's go down to the next one. Now this one's a little bit tricky and applying your knowledge of converting from fractions to ratios a little bit further. So it says here, at a football game, the ratio of adults to children is 4:1. So the ratio of adults to children is 4:1. The adults are all either men or women. The ratio of men to women is 8:2. What fraction of all the people are women? Well, what we need to do first is we need to find out what fraction are actually adults. So here I've got 4 parts are adults and 1 part are children. So I've got 4 parts of adults over, now in total I've got 4 parts, add 1 part, which is 5 parts. So I know 4/5 are adults. Now let's work out of those adults, what fraction are women? Well, 2 parts are women out of 2 parts plus 8 parts, which is 10. So I've got 2/10 are women. Now, if you think to our and or rule, our and rule tells us that we need to times. Our or rule tells us we need to add. So what I want to say here is, what fraction of the audience are adults and women? Okay, because they satisfy both of those. They're not just women, they're also adults. So what we can say is they are an adult and they are a woman. So in order to do this, we need to times the fractions together. Now to times fractions, we do 4 times 2, which is 8, 5 times 10, which is 50. Now if we want to simplify this fraction further, I can divide the top and the bottom by 2, which would give me 4/25. So that is how we would find a ratio to a fraction when we've got 2 different ratios. So as a little bit of a tip, if you've been given 2 sets of circumstances, you know you're probably going to have to times them. So what I would like you to do now is pause the video and have a go at this set of questions. Once you've had a go, make sure to press play and we'll go through them together. Okay, so hopefully you've managed to have a go at those. Let's have a look at this first one. In a bag there are blue sweets and red sweets. The ratio of blue sweets to red sweets is 2:7. What is the fraction of sweets that are red? So, red are 7 parts out of the total number of parts, which is 2, plus that 7, which gives us 9. So 7/9 should be your answer for that. The next one, in a bag there are blue sweets, red sweets and green sweets. The ratio of blue sweets to red sweets to green sweets is 2:4:5. What fraction of the sweets are red? Well, we've got blue, then red, then green. So the red one is this middle one here. So 4 parts of the sweets are red out of the total. So let's add those up. 5 parts, add 4 parts is 9 parts. Add on another 2, gives us 11. So the fraction of sweets that are red is 4/11. The next two now focus on going from a fraction to a ratio. This question says, in a bag there are only blue sweets and green sweets. 5/6 of the sweets are green. Write down the ratio of blue to green sweets. Well, if 5/6 are green, we know that 1/6 must be blue, because 5/6 add 1/6 is 6/6, which is a whole. So the ratio of blue to green, well, 1 part is blue and 5 parts are green, because we're using that numerator there to tell us how many parts there are. Now the last one, this is looking at that tricky question we did at the end. It says, in a cinema, the ratio of adults to children is 3/1. So adults to children is 3/1. The children are either boys or girls. The ratio of boys to girls is 3/2. What fraction of all the people in the cinema are girls? So let's have a look. The girls are going to be children. So first, let's find the fraction of children. We've got 1 part of children out of 4 parts in total, because the 3 add the 1 gives us 4. Now, what fraction are girls? So I've got 2 parts of girls out of 5 possible parts, because 3 plus 2 is 5. Now, using the and or all rule, I want to say that they're children and they're girls. So I times these together. 1 times 2 is 2. 4 times 5 is 20. So I've got 2/20, and I can simplify that down to give me 1/10. So 1/10 of all the people are girls. Hopefully that's helped you give you a little bit more of an idea about how we go from fractions to ratios and the other way around. In the next video, we will be looking at going from ratios into percentages, which kind of just develops this skill a little bit further.